Namaskar, my dear friends. We have a question that this is the particular circuit we have, and we have to identify what is the state space model for this particular circuit, right? So you guys already know we have a state space model in terms of x dot is equal to ax plus bu and y is equal to cx plus du, right? So where a, b and c and d are the matrices, as you can see, we will have a as a state space variable matrix, which will be a11, a12, a21, a22, something like that. B and C and D will be there, right? In this question, they have already mentioned it. The find the state space model with the state variables defined to be what? X1 as IL, okay? Means IL is nothing but the current flowing through the inductor. And X2 is VC. VC is the voltage across the capacitor, right? And we have the output y of t, which is going to be IL plus VC, right? So my y of t, that is the output, which is going to be IL plus VC, that is inductor current plus capacitor voltage, right? So let us solve these questions quickly. So what we can do is, we can do one thing. Let us say this is my IL that is already there, okay? And this is the current that is flowing through this, which is IC, okay? Now, the current flowing through this resistor will be what? R1 will be what? IL plus IC. Okay. And you guys already know that it was given my state variables were x1, which was IL, and x2, which will be VC, right? So it was VC. And we have y of t, that is output, which is going to be, what was that? It was IL plus VC. IL plus VC. Okay. So with this, you guys already know that this is the equation x dot is equal to ax plus bu and y is equal to cx plus du. Based on these equations, we'll try to understand how we can put this particular equation into a state space model. Okay. Alright, so let us try to understand like this. Can we write it down like this, that x1 dot is equal to a11 x1 plus a12 x2 plus b1 u or b1 u of t, okay? Similar to that, can we write down x2 is equal to a21 x1 plus a22 x2 plus b2 u of t, okay? So these things we can write it down like x1 dot x2 dot in terms of ax plus bu, where b1 b2 are the coefficients of B matrix and u is the input, okay? We'll change the input based on, like what is given here. That is nothing to worry about, right? Now, if we have x1 is equal to IL and x2 is equal to VC, so can we write down x1 dot is equal to differential of IL, that is x1 dot is equal to dIL by dt is equal to, similar to that we can write down continuously this one, a11 x1 can be written as IL plus a12 x2 can be written as VC plus b1 u of t is your input, so that is nothing but your v of t is your input, right? So I can write it down v of t. So this is my equation number, let's say 1. Similar to that, I can write down x2 dot is dvc by dt, right? So this dvc by dt can be written as a21 il plus a22 x2 is nothing but vc plus b2 and u of t is nothing but v of t, which is your input. So let us say this is my equation number 2. So you have complete equations now, dIL by dt and dvc by dt, which is in terms of this one. Our aim is to identify what is my A matrix, which is going to be A11, A12, A21, A22, okay? And the matrix B, which is going to be B1, B2, and the matrix C, which is going to be C1, C2, something like that, okay? All right, so let us write down some equations here. Okay, so what we can do quickly is, we have this particular circuit, right? Okay, so this is my R1, this is my R2, this is my C, and this is my L, and the current flowing through this is IL, and the voltage across this is VC, and this is the voltage which is VT, right? Now we can see that the current flowing through this can be written as IC, and the total current flowing through this can be written as IL plus IC, right? So this is all that we can write it down. Got it? Now, if we write down a loop equation through this, then can we do it one thing? Let us write down KVL, the voltage loop equation. Okay, so it will be minus VT plus R1. What is R1? R1 will be this, across this total current is there. So can we write down R1 into IL plus IC? Okay, plus R2. So what is the total current across R2? That is R2 into IC. Okay, then plus the voltage across this capacitor is VC. So that is going to be equal to 0. So this is my complete equation. So if you want, we can solve it like this. My total, this equation will be in terms of V of t can be written as, all these terms will be taken right side. So V of t will be right side, so that will become positive, and all these will become negative, right? So I can write it down, R1 times IL plus IC plus R2 times IC plus VC of t. Now our aim is to convert this equation in terms of input and output, as well as x1 and x2, right? So you remember, your x1 was IL and x2 was IC. So we have to have the terms separating with only IL and IC. Okay, so can we write down something like this? We can do one thing is, R1 into IL plus IC is common, so I can write down R1 plus R2 into IC plus VC. Okay, now let us do one more thing here. We need here VC, right? So can we do one thing? Wait a moment. X2 is actually VC. Okay, so what we can do is, we have X2 is equal to VC. So our aim is to convert this particular IC in terms of VC. So can we write down my IC is equal to, this voltage will be what? Let us say this voltage can be written as VL, the voltage across the inductor, and this voltage will be written as VC. So can we write down VL minus VC by R2? So my IC can be written as VL minus VC by R2. Okay, so in that case, can we write down something like this, R1 into IL plus R1 plus R2 multiplied by IC, which is going to be VL minus VC by R2 plus VC. Got it? Now after solving it quickly, so what we'll have? We can have it something like this, that R1 into IL plus, I can write it down VC, right? So VC terms I can take it separately, right? So I can write it down R1 plus R2 by R2 into VL, and this will be minus this thing plus VC. So that if you do, what is going to happen? Minus R1 plus R2 times VC by R2 plus VC. If you solve it, then you are going to get R1 into IL plus, this is going to come up as R1 plus R2 by R2 into VL, and this is going to be, see, R2 will get going here, so R2 into VC and minus R2 into VC will get cancelled. So only we will be having R1 into VC by R2. Got it? So now we have here V of t, that is this equation. If we take VL term left side, then what will happen? Because we need now IL is there, VC is there, and VT will be there, which will be the input. So input I can take it this side, so VL will be that side. So can we do one thing like this? Wait a moment, this is not 2, this is R2. R2. All right. So if we do that, then we are going to have R1 plus R2 by R2, okay, into VL, which will be equal to, what will happen? This will be minus R1 into IL, and this will be plus R1 into VC by R2, okay, and this will be plus Vt as it is, okay. So Vt is as it is, so this will be going that side, so plus, and this will be going that side, so minus, and this will remain as it is, right? Now if we quickly do that, then VL can be written as LdI by dt, LdIL by dt is equal to, I can divide both side by R1 plus R2 by R2, okay. So what will happen? I can have here minus R1 R2 by R1 plus R2 into IL, right? Plus this one, it will get divided by R1 plus R2 by R2, then R2 R2 will get cancelled. So we will be having only R1 by R1 plus R2 into VC, and plus this will be having R2 by R1 plus R2 into VT, okay. So this is my equation number, let us say 3. So can we quickly tell that this is going to be my A11? Or wait a moment, what we can do is, we can take L right side. So if you divide both side by L, then you are going to get DIL by dt is equal to, L will come down, so it is going to be minus R1 R2 by L times R1 plus R2 into IL, plus R1 by L times R1 plus R2 into VC, plus R2 by L times R1 plus R2 into Vt. So this is, let's say, my equation number 3, okay. This will just remove it right now, okay. So this is my equation number 3. Can we tell that the coefficients of IL can be considered as A11, this will be A12, and this will be my B1, okay. So this term, this term, this term, and this is my nothing but x1 dot. Got it? So similar to this x1 dot, we can have x2 dot also, okay. So let us take same equation again. This is the equation, loop equation that we had written. Vt is equal to this one, right? So this equation we'll take again, and we'll try to solve it for x2, which is going to be Vc, okay. So that this is how we'll be getting dVc by dt in terms of x2 dot, okay. So let us write that equation. We had the equation Vt is equal to R1 into IL plus IC plus R2 into IC plus VC. So this was the equation. So can we write it down again separately, IL and IC separately? So we can write it down R1 into IL plus R1 plus R2 into IC plus VC. Right? Now, can we do one thing? We can have, since IC we don't need, right? So IC we have to have separate. So IC will take right side, left side. So what will happen? R1 plus R2 into IC is going to be equal to, this term will become minus, this term will become minus, and this will remain as it is, right? So we can have minus R1 into IL plus minus VC plus V of T, okay. So this is how we are going to get. Now if we know IC is nothing but across a capacitor, IC is what? C dVc by dt, right? So I can write it down something IC as C dVc by dt. Got it? And R1 plus R2, I can divide both sides, so this will get cancelled here, and this will come something like this. So we can have minus R1 into IL by R1 plus R2 minus, this is going to be 1 by R1 plus R2 into VC, and this is going to be plus 1 by R1 plus R2 into VT. Now it becomes very equal, very easy. So if we can divide it by C, then we are going to have dvc by dt is equal to minus R1 by C times R1 plus R2 into IL minus 1 by C times R1 plus R2 into VC plus 1 by C times R1 plus R2 into Vt. So as you can see, this is nothing but my x2 dot, okay, which is dvc by dt, since x2 was Vc, and this is my A21, A22, and this is my B2. So as you can see, all these coefficients we have identified. So in state space model, we can very quickly write, what is that? From this equation number, let us say 4. So equation number 4 and equation number 3, we have the coefficients of matrix A, right? So we can note down those equations and we can write down something like this. What we can write? We can write it down as matrix A will be, what is that? Minus R1 R2 by L times R1 plus R2. Next was R1 by L times R1 plus R2, and A22 will be this one, A21 will be this one, which is minus R1 by C times R1 plus R2, and this one will be minus 1 by C times R1 plus R2. So hope you have a good understanding now, and you can see my matrix B will be the coefficients of B1, which is going to be from equation 3, which was what? R2 by L times R1 plus R2, and B2 will be 1 by C times R1 plus R2. Okay. And coming back to the y of t, so you know already my y of t was what? IL plus VC, IL of t plus VC of t, right? So you can see, since the equation is in the form of IL and VC both, so we have C as 1, 1, okay? So this is complete equation, okay? So we can write it down in terms of like this, which is going to be x dot is equal to AX plus BU, and y is equal to CX plus DU, okay? So in that case, this complete equation can be written as A, B, C, D matrix we have with us. So we can write it down as x1 dot, x2 dot is equal to A matrix, you can write it down. I'm just leaving it blank, okay, into x. So x will be x1 of t, sorry, x1 of t and x2 of t, okay. So this is my Ax plus B matrix I am leaving you, and which will be B of t. So Ax plus Bu. So this is going to be matrix A, this is going to be matrix B, as we just now wrote. And my y of t will be Cx. So that is going to be 1, 1, and this will be x1 of t and x2 of t. So hope you have now a good understanding of this complete representation of state space model of the given electrical circuit, okay? So this was the circuit solution in terms of state space model, how to identify the state variable matrix, the input matrix, the output matrix, all these things. So hope you have a good understanding now, okay? So if you do have any questions regarding the state space model representation of any electrical circuit based on the given equation or given questions, you can put down your queries in the comment box and we shall be able to answer you out. Thank you so much.